Welcome to this first chapter on 3D point cloud processing with Python. This is part of the series of open workshop on 3D data at large, and we are going to focus onto the base layer, the foundation, 3D point cloud processing, and Python, how to get started. Without further ado, let's dive right into our workshop. All right, so 3D point cloud processing with Python. So basically, at the end of the workshop, I will send you the recording that is happening right now. I will send you the code with the license to use it freely and the dataset as well. And on top, you will have a handout, so a cheat sheet that should summarize everything on one nice piece of paper that you can print out if you want. So let me start about what we're going to do here. That's just an example, right? I just want to show you how to start right off the bat from scratch. So I will need to adjust a bit depending on where you're from. And with Jean-Jacques here, we will also give you some hints about how to best set up your environment. We'll speak about the various ways you can set up your environment and the various ways you can code for 3D point cloud processing with Python. This is definitely going to demystify the learning curve to get started with point cloud, and also hint about the great lines that will be interesting to explore, right? So just a small tip, whenever we are following a data processing line, whereas you are already a professional or a researcher or students, there are some specific aspects that you can generalize, and usually it's a good strategy to try and generalize as much as possible, so that whichever stuff you are coding, creating, innovating on, you have the ability to just use this and reapply that for another application. That's not so easy, but we are getting and starting to see some nice approaches also playing on deep learning that start into this generalization, let's say, track. There is one big thing that I remember, that's when I started my thesis, which is now almost 10 years ago. I wanted to push a lot into what we call AGI, so artificial general intelligence, but at the time that was like something science fiction. Now it's closer than ever. We're starting to see some very nice systems that are closing in the gap toward a generalization using AI. It's not yet there, but for example, if you follow last year's evolution, there was one nice architecture was pushed by Meta called SAM, so Segment Anything Model, which was for images and could generalize really well to various applications with this unsupervised framework. So all of this to say that it's very important whenever you're constructing something to be able to generalize as much as possible. And the second thing is to try to have as minimum breakpoint as possible in your pipeline. So if you align a lot of pre-processing steps or processing steps down the line, it can fail. So the idea is to be lean, and whenever you choose something, that it's something that can really span out to other applications. So let me maybe clarify a bit what that means with point cloud. You can see here various point clouds. From what I scanned a while ago was just a room, I think, from an apartment I lived in back in the days. And you have three strategies. You have the random sampling on the left side, where you have the full point cloud. And for a lot of processing application, we need to sample. Either it's sampling just for, let's say, making sure you can test things without having heavy computation, or it's sampling for having the ability to extract like too much data that is not really relevant for an application or for the applications as well. So the random sampling, basically, you sample based on the ordering of your point cloud. So you will take 1 line out of 10th or things like this, which makes something on the left side. On the middle, you have spatial sampling. So here, what you have is basically creating or extracting the mean distance through various points around each point, and extracting 1 point every 2 centimeters, 5 centimeters. You can specify that. And on the right side, you have a voxel grid sampling, and I will elucidate a bit more on that. And that's what we are going to unlock at the end as well the ability to switch mode of representation. I will not be able in 1 hour and now compressing that with this little hiccup at the beginning, but basically will not be able to touch onto two advanced, let's say, multimodal strategies today. But definitely along this year, I hope that we can continue in this let's say, line of things and have the ability to share with you this multimodal processing and so on. All right, so now what will be the initial thing that I need to maybe show you? Can I here plot something? So what is that? Oh yeah, that's a stylus. Very good. So yeah, let me give you a bit of a background. So here we will have a point cloud, right? Which is like this. And the idea will be to explore the basics after setting up everything and pre-processing this data and also creating a voxel structure on it so that we allow two major approaches down the line. So for later on, which is the point-based approaches for example, machine learning and artificial intelligence, or voxel-based or structure-based approaches. So what does that mean? Your point cloud, which is here in purple, sorry, I'm losing my English. The point cloud here has various points, right? And all of that is specifically a point, and that has maybe an index 6, 7, and 8. And in your computer, how this is displayed is basically a list, a CSV. You can have that, where you have your index until 8, right? And for each index, you have any number of features. You usually have 3 main features, so X, Y, Z, your coordinates, right? X, Y, Z, with some numbers. And after that, you have several attributes. You usually have RGB if you have a passive sensor that could capture that, and you can have extra attributes as well. Okay, so that's how it looks like. And basically, whenever you do a search, or if you want to do something, you directly see that here you have absolutely no link between all of these points, right? So yeah, I could do that, and then that's this field as well. So that's why we call this point cloud unstructured data set. So that's unstructured. And this is something unstructured. And this is something that is pretty hard to handle for a, let's say, a computer in general, but also for processing applications. So going to a structured entity will make it much easier, and I can make a parallel with images, right? Images, it's a structured data set where you have basically a bunch of pixels which are all close to one another. So it's a grid structure. And structuring our data set in a grid will make it very easy to process, especially with convolutional neural network, right? Or going onto like architecture, like well-established deep learning architecture that are really good at handling structured data set. For unstructured data set, there are some architecture that does this, for example, PointNet, or we have to develop some smart tricks to do that. So here, I want to make sure that you have the ability to play on both like modalities. And to go from point cloud to voxel, basically, the idea is very simple. I will draw it here. You have your point cloud again. I hope you see my screen, and don't hesitate to stop me, Jean-Jacques, if there are some questions in the chat. I forgot to ask now that we have enough people, and if things are not clear, that's the idea here, is to be as interactive as possible, to take the opportunity to ask questions, and hopefully to solve your issues at the moment, or to give you a hint that will take longer else. So don't hesitate, really, we are there for that. So on top of that, I will create my voxel structure. So basically, that's my point cloud. And the voxel structure will be a bunch, like putting a grid on it. And my grid will be divided into like a specific number of voxels, let's say like this and like this. So this is a voxel structure that could be linked to an octree structure. I will speak about that a bit later as well, where you see that, for example, this voxel here, we'll use another color. Oh, but no, it's already green. So that this voxel holds 2 points, right? This one holds 2 points as well. This one holds 1 point at the border, and so on. So basically, we will attach, each voxel will be a unit, which structure or space, and we will know if this one is filled or empty. This is an empty voxel. This is a field with 1 point. Here you have 2 points, and so on. And basically what you do after is create that structure and abstract it as a Python object, and we'll be able to use that. So that is that simple. And based on that, we can have, for example, sampling strategy to extract for each voxel that is filled, the centroid or the point closest to the centroid, right? These are things that we can do very easily. And then, of course, having that, you always have the ability to fall back to your point cloud, which is unstructured as well. So it makes it very handy to play on both, let's say, modalities. Right, we'll go on to these 5 phases with environment preparation, data preparation. Then we'll take one single unit, make the experiment. After that, we automate and scale, and we visualize everything that we have. So Brazil, awesome. Happy to have you here. Barbara and Stahl from Ghent, very cool, very nice city. Vigo, awesome. So I really love it that we are representing a lot of part of the world. I didn't saw people there from, let's say, Asia. So Norway, awesome. Montreal, very cool. Yeah, because I always struggle to find a nice time slot that fits all time zones. So hopefully this one works, because my idea is to have a regular every month like open workshop there that we can build on, so that we here build the foundation, and after we'll grow from that. Very good. Yeah, Jean, boring place. Yeah, you're welcome to come here for a few weeks if you want. Maxime Rent as well. Oh, okay, so many people from Belgium. Very cool. India, very cool. All right, so let me now dive onto a little bit of Python. Maybe I can start from scratch. I will show you one way to set up very easily and to demystify how to get started. One way to get started very quickly is to get on with Anaconda. I will zoom in a bit, and you can go on to free download. They changed their website, and you take the one from your distribution. All right. So Anaconda, you have 2 things to know. Is you have one distribution with the GUI, which I had open here, which if you are first starting out with Python, I would recommend that, because it abstracts a lot of things. But then when you move on to being like better and better at Python, it's very easy to move on to command line interface like this, which will make it easier and maybe more straightforward. But I will show you both ways if I have time today. And then with Jean-Jacques, we'll show you also various IDEs and what are our favorites. So once you download that, you install it. The other possibility, if you want something very lean, will be to get started with Miniconda. And here you have also various distributions. So you have an installer, and once it's installed, basically the same ways to go. So once it's installed, if I launch Anaconda Navigator like this is what I get. We'll close that. And here it's a list of environment that I have, right, on this computer. See that I have a lot. Usually what I do is when I start a project, I create a new environment. And to do that, so that's where all the ideas on my environment. And an environment is really something that allows you to escape some kind of conflicts of dependencies and things like this. So it's very easy. You create an environment called, for example, first base or first touch. You install Python 3.9, which is very good. I don't recommend to take the latest version, especially when you use a lot of libraries. It's very often that you will have something that breaks or it's not supported. So sticking with 3.8, 3.9 is good. 3.10 is okay, and above it's a bit it's a bit much with 3D processing. right? And once you do that, basically it will create your environment, and from there we will install various libraries that we'll use and leverage, and you can see what is installed, for example, into this chapter 3 library. That's already a hint that, yeah, I'm writing a book with O'Reilly, and that's a chapter that deals with a lot of stuff there. And basically you can see when it's installed with Anaconda or pip. Whenever it's like this, it's installed with pip, this little icon, and this is installed with Anaconda. So now let me see how I can create an environment maybe from scratch, and we'll install 2 or 3 libraries. Hopefully it goes quick enough. So I will kill that, and I will type Anaconda, and you see that I have Anaconda prompt here. I will just execute that as an admin for now. And in here, I will zoom in so that you can see better. I will do a conda env list, and this will list exactly what you saw, all my environment that I have installed so far, right? And you can see where they are at the moment. So one thing to do would be to create a new environment. So for that, you do a conda create new, and you put the name of the environment that I will create an environment. For now, I will just do conda activate. And let me take chapter 3 because it's fresher in my mind, so I know that I have the libraries installed here. And automatically, it will go into this environment, and you can see that because it's here, right? And from there, you can install libraries that will allow you to get much quicker at coding stuff and using stuff that is already algorithms that are already implemented. And for that, I recommend for now to use pip, and you make pip install and the various libraries. So here I could do pip install Laspy. It's already installed. If I do that, I think it would tell me error. So it's normal. Yeah, Laspy, sorry. So pip install Laspy. It's already satisfied, it's okay. So that's what I will use Laspy to load LAS datasets. Then I will use Numpy, so pip install Numpy, and you can list things next to one another. Open 3D for manipulating 3D object, and we'll be good to go for today. So once that is done, basically you have an environment which is set up. So you can see that it's very, very easy. The next stage is installing an IDE. And at this stage, an IDE will help you get much better at coding or have a quicker turnaround between debugging and having something which is handy to work with. So instead of using Notepad or things like this. So an IDE, you have 2 main IDEs families. You have notebooks and you have Python IDEs. Like usually people are familiar with Google Colab, or which is a notebook-based environment, or Jupyter Notebook, which is very fine, and that's why I will show you Jupyter. So you could install very easily the same thing, pip install Jupyter Lab, and that will install Jupyter Lab. And then after that, everything is installed. I will just show you maybe Spider does. Do I have it installed here? I'm not sure. No, I didn't install it here, but I will show it to you later. So basically what I did here is I had Anaconda installed. I created an environment called chapter 3. And in this environment, I installed 3 libraries. So Laspy, Numpy, and Open3D. And after that, I installed my IDE, Jupyter Lab. Once that is done, I will launch Jupyter Lab. Just one thing though is it's a good practice to launch it from a specific folder where you have all your data sets and your code. And for me, it means that I have to switch to another drive. And as you can see here, usually what I do is I have 3 folders, code, data, and result. In the code, I will put my code. In the data, I put the data that you will have available. And in the result, it will be what you get out of your scripts, right? So then after that, I will move to my code folder, take the path, and just make a change directory. And I put my paths there. And from there, I will launch Jupyter Lab. Jupyter Lab. I make a space, and I press enter. And as you can see, it opened Jupyter Lab from my code folder. That will make it easy to handle where the data is stored or not. All right, so now we get started, and this hopefully will demystify a bit how you can get very quickly with Open3D and Python for 3D point cloud processing. So the first step that I usually do is I will import the library that I installed in my script so that I can use them. As you can see, I make an alias here, like Numpy as NP, Open3D as O3D, Laspy as LP. What I do is Shift Enter, and that will execute my little cell here. Then I move on to step 2. I don't need to re-import Open3D. And what is happening is I create a variable PCD-O3D where I will input my data set. You will see what it is from my data folder. And then I visualize it with this little function. So 2 lines of code. And when I press that, you will see that very quickly you have your window here, right? And hopefully that gives you good vibes of holidays. It's a bit far from me. I would love to go back to the beach anytime, but it's not for right now. Too much at the moment. But as you can see, you have your point clouds, all right, that you can visualize already. Just to give extra knowledge, that was made, I think I made that in 2016 when I went there, and it's just a bunch of pictures that I took, and then I used 3D reconstruction mechanism to create the 3D point cloud. It's going to take a lot of place this year because we have new technologies which have this big hype around it, which is NERF and Gaussian splatting, which essentially build on photogrammetry and photogrammetric reconstruction, but then add some elements either for modeling or for having a nicer way to visualize stuff with Gaussian splat instead of just points on the screen and projections. Right, so it's very easy. As you can see, you have your point cloud, you load it, and then you visualize it. The second thing that I have is I import Laspy here, but I did it already there, so I will delete that. And I will load my file with Laspy. So lp.read, very easy, and I pass my point cloud. After that, you have to know that it's a LAS Laspy object. So we have in Python, everything is an object. We have to switch this Laspy object to a Numpy object to be able to handle that more efficiently, because Numpy is a computing library, very nice. And to do that, you just take out already built-in function into Laspy that extract the X, the Y, and the Z, and I have it transposed. And I will take the points and the colors, RGB. What you have here is, because my point cloud is coded with integer 16 bits, which means that I need to pull that down to a float colors mode of representation between 0 and 1. That's just a little trick that could save you some hours of thinking when you get started. Why does it not work for me? So I press that, everything is loaded, and as you can see here, it's for now we have a Laspy object or Numpy object, and I just want to show you how easy it is to get to Numpy or Laspy object to an Open3D object, which has this nice way of visualizing data sets. So for that, I just create an object of type point cloud, and then I pass to the points attributes the points, and to the colors, and then I visualize. So that's what I do here. And then when I press it, it should normally, I hear my computer which gets excited to display stuff. You can see the point cloud now that displays, which is an aerial point cloud from Wellington, so New Zealand. Very cool, that I played a bit around with to color things in blue and green. So yeah, everything is working fine now. Whether you have Open3D PLY object or LAS object, you have a way to load that and prepare your data. Now I wanted to check out with you how to create data structure, and also show you some tricks around bounding boxes extraction, because some of you are using that. I just check the question at this step: how to make new environment. Yeah, so how to make new environment? Good question. So I will not do that from here, but basically, if I open Anaconda Navigator from there, this is what I showed before. You can just create a new environment, or conda create new environment. We'll show you thereafter. May we have this command line too? Yes, I will put everything at the end. Basically, you will have an access. I created a course, but it's not really a course, it's just a place where I will put after every workshop, I will put all the things, the scripts, the recording, the command lines, everything at one place. I didn't find any other system to pack everything there. So yeah, basically we'll have that all at the end. Is there a current practical alternative to ColMap for point cloud reconstruction from photos? Yes, you have. I recommend, I think I shot a YouTube video recently where I show Mushroom alternative to create 3D reconstruction with open source software with photos. Else you have reality capture, which is really nice. This one, reality capture, or you have context capture. Context capture, which is now called I think it's iTwin now. It's called iTwin Capture Modeler. This is also very nice, but both reality capture and iTwin are paid software. But reality capture will be my favorite go-to software for computing efficiency, because the guys there did very smart tricks at inverting matrix, which makes it very, very efficient when you're computing stuff. And after that,
add some other. They have also Mushroom, that's harder to reconstruct, and Agisoft. That's
Agisoft Metashape, yeah. We are not affiliated to anything. We are just trying to get as transparent as possible. So don't hate us if you are working for another company that creates 3D reconstruction, like 3D Zephyr. That there are a lot now. There is even like AI-based reconstruction, like Luma AI, that works with basically ColMap under the hood. But yeah, you have a lot of alternatives. And one guy which is very, very good and developed OpenMVG is called Pierre Moulin, and he's still working hardly on that to create more open source things around that. All right, the employee libraries are using the CPU for now, not the GPU. As always, I always recommend to try to limit how you work with GPU, especially if you put things on server-side computation or SaaS platform, especially 3D deep learning, train on GPU, but inference on CPU only is my recommendation. All right, let me get back to the course. Just quickly with a GUI for answering the question, how we create environment. You just go on to environment, create, and new env, that's your name. You click on the Python version that you want, and you click on create, and it's created. That's the easiest way to get started. I see the time is running very, very fast, so let me get back to the scripts. Now the data structure. So what do I do here? I have a temporary data. I want to show it to you, which is actually a strip from the data set that we have, right? I didn't load the color at this stage. I want to show you something. Oh, not the camera, sorry. I want to show you something around bounding boxes. You have the ability with Open3D to handle bounding boxes. So if you go into 3D object detection, that will be very handy for you. So basically you have oriented bounding box and axis aligned bounding boxes. Oriented bounding box will try to align the bounding box to the best fit PCA axis, whereas the axis aligned bounding boxes will just take how your point cloud is in space and make the bounding box around it. So what I do here is I compute both, and then I give a color for the oriented bounding box, which is red 100 RGB and blue RGB. So this is blue. And then after I visualize my 3 elements Open3D, so my point cloud, temp data, the oriented bounding box, and the axis aligned oriented bounding box, axis aligned bounding box. And I pass that as a list of objects, and that is very nice that you can do that with Open3D. And as you can see, you have here the axis aligned bounding box, and here you have the oriented bounding box. And if I switch like this, you see that it's an oriented bounding box that also follows the z-axis because it's going a bit down as well. So that is very interesting, especially if you want on top to extract like the main axis of your data set. Okay, now let me show you what you can do as part of structuring. If you don't know what an octree is, it's basically a data structure that you put on top of your point cloud, for example, to accelerate a lot of the computation or the search action that you do on your point cloud. And basically, you have a depth level. So the lower you go, the smaller at the end you have the nodes, which you have an equivalent. A node is a voxel. So basically, you have your full point cloud, you put a cube on it. And every time you go one depth level, you divide your cube into 8 little cube, 1, 2, 3, 4, 5, 6, 7, 8, right? And after that, you take one cube and you go down and you go down and you go down. So here, for example, I say I want to go down to the level 7, and I want you to draw my octree. And as you can see, what I explained to you is exactly what we get. The lowest level is my voxel, actually, and the more we go up, the more you see the structure, the initial structure. So the level 1 has these 8 big cubes, and then you refine that and you refine that. And this kind of structure are very, very handy for any process that you do whenever you want to structure a bit or speed up your computation. Okay, so very cool stuff. Octrees, I really love them. That was just to show you how you can create quickly a data structure. Now, let me move on to step 4 and showing you some subsampling strategies. And as I said before, if we were to take 1 point every X line, like 1 point every 160 line, this is what we will get. I will play that, and at the end, instead of having 5 million points, we have 31,250 points, right? And all I do is put the factor with that in front that will make it decimated. Now, let me show you how you get a point cloud voxel grid and get a bit onto the specificities here about what we spoke about before. The first thing that I do is I define my voxel size as, how big is my voxel? And here I put 6 meta. What I do after is I just sort out and I take only the point that has the biggest coordinates and the smallest coordinates, which will help me define, let's say, the number of voxels that I need to create, okay? And that's what I do here. The cell will basically get the lowest integer value available, and I do that based on these 2 components, and I divide by the voxel size, okay, which I have here, which will help me exactly know how many voxels I need to create along each axis. So if I execute that, I have 254 voxels that I will have along x-axis, 154 along the y-axis, and 51 along the z-axis. And basically, I will fill my space of voxel of size 6 meta following that, right? And it's very important to understand that here, you see that I don't work with the direct coordinates. If I were to put my max point, you see that it's not an integer, right? That's huge coordinates. But doing that will make sure that we can work with integers going from 0 or 1 to 254. All right. So now the next stage is that I will compute non-empty voxel. And to do that, the trick that I use here is basically I take all of my points and I subtract the mean value, right? To get close to this 0 element. So it's a translation. And then I take only the integer part. So it's a modulo here, right? And I divide by the voxel size and I retain as an integer type. And once I have that, what I do is actually filter out and only take the voxels that are unique. So I don't want to have 2 times the same pointer. I want to make sure that it's always 1 time the same pointer. And then after I order them, growing from 0 to the rest. And then you can check out how many non-empty voxel I have at the end. So I execute that. Whenever you have this little asterisk, it means that it's computing with Jupyter Notebook, and I have 2 million voxels. Yeah, 2 million and something voxels. All right. So very good. And what I do after, in this little cell, I wrote it, is I store the voxel indices as key. Maybe I could show how it looks like, a voxel index from there. It's basically keys. I don't know why I have minus. I think I made something at any point there because of min p maybe. Yeah, that may be it. Let's check out if this is correct or not. I store the related pointers value of each key. I compute each voxel barycenter and the voxel closest point to the barycenter, and I add it to the list. This is what is done in this little loop. I will still check out what we have. So that is using Matplotlib. It's a way also to visualize your point cloud. I took the decimated one here, as you can see, and the color, I also take the decimated color. And here it's just to save voxel base point. I will put live in front so that we know it's live, and we'll check out what we have from this little saving function from Numpy. Yeah, I think Jean-Jacques, I think I screwed up the the experiment. I changed something because I had to help a company on some stuff, and I think I forgot to save before opening. Anyway, I will fix it whenever I put the code live afterwards. Yeah, because here that's not normal that it's working for so long. So let me still check what we get in the results. So the live is still constructing. It's much too big. I don't know what he's doing. 5 seconds, yeah. Still, I will open it. So as you can see, that's the live, and I will put it here. Or maybe it's because I put too much voxels. Oh no, I think it may have worked. Oh, no, it worked, sorry. Just that I put too much voxels. How many points do we have? 2 million. Yeah, that's correct, right? It was exactly that's the length. So basically what I have now, it's a sampled point cloud where I took the point closest to the centroid for each voxels. So that was one way to use the grid structure in pre-processing techniques, but you have other possibilities as well to use that. So I could extract directly the voxels and create a model based on the voxels as well. So things are working smoothly, which is very nice. And then here, basically what I do is automating. So I take all the code that I have here, I put it in a function. That's how you define a function in Python. I call it grid subsampling, and I pass my points and the voxel size. And there's arguments, or there's, let's say, variable will be used internally in the function and return the grid candidate center. You can basically adjust everything to return something else, and then all you have to do is to use this function with a specific size of your voxel, and at the end you can save to a new variable. So here, if I put 15, automated, live automated. So let me just do that and that, and we will check out what we get from our little function. Hopefully it runs a bit quicker. We will see. Yeah, it's 29 milliseconds, so it's quicker. And now I have my live automated sample, and I will drop it in Cloud Compare, which is a nice software if you do not know, for visualizing point cloud and playing around with that. And as you can see, we have the result, which is very cool. It's basically subsampling based on the voxel data structure. So that was a very quick intro to the world of 3D point cloud processing with Python. Let me get back to the presentation and speak a bit about how that relates to AI and all the wonderful stuff that we have after. So basically, to help you there, that's what I try my best to do as much as possible this year. And I am here with Jean-Jacques, which joined, let's say, this mission to push as much knowledge as possible in two forms. So the knowledge that you will get at the university is very good, but usually it's lacking a bit of hands-on knowledge. I saw that a lot with the teams that I manage, and I still manage in various industries. It's very important to have this know-how, so skills, by having knowledge and hands-on knowledge. That's what it is. And that's what I'm trying to do with Jean-Jacques, pushing that as much as possible in two forms. Whatever you can find on the web, usually you have the tutorials on Medium, where you will have most of standalone aspects that will deal with 3D point clouds, 3D deep learning, 3D object detection, 3D reconstruction, directly open there. I started a YouTube channel beginning of the year where I push, let's say, once a week a tutorial, also targeting something that the community in the geodata community says that they would like to have. And then after, I do some research and courses outside of all of this with various universities. But basically, I would recommend, if you want to have access to all of this, get onto the 3D newsletter at learngeodata.eu, the 3D Geodata Academy, where you have everything available. Let me get the chat for the YouTube. Yeah, I can check that. So I can check that. For the YouTube channel, I don't know exactly the handle, but basically if you type Florent Books, I think you have that.
Yeah, I will give the link.
Yeah. Yeah, okay, great. Thanks,
so you can continue.
Yeah, presenting. Yeah, thanks a lot. And then on the right side, you have the pay. The distinction is really, for me, a way to grow much quickly. Basically, on the right side, you have production systems, things that you can take and apply to a specific challenge, or to directly have a solution from which you can create your own company from, your own venture from, or help the company you're working with develop new stuff. I had a lot of wonderful feedback from the student there, and hopefully there are some in the chat as well. I saw Jean that already applied so much and grew so much and created so much like crazy stuff with that. So I'm definitely very, very happy about that. So if you are at this level where you are not a beginner anymore, that will be the fastest way to grow in 3D data expertise and 3D data science. Whether it's the course, the books, so 2 books are coming, one with Elsevier and one with O'Reilly, that dive into 3D data processing at large. And of course, if you're a company, we also do some consultancy and advising, mostly related to R&D and implementation of new, let's say, new framework, new technologies. Right. So for the course, one thing that will not change, and if it does change anytime, please be angry at me, because my goal is to make sure that we escape any low-cost schemes and things like this. And every time you are following a course, because this technology grows so fast, I think it's very important to have this support and updates about what is important to watch, and also to try and bring down a lot of stress from being overwhelmed by the amount of stuff that's coming up. I mean, there are a lot of papers now from research, and also my PhD students as well, that are overwhelmed by the amount of papers coming out every day, and it's bringing a lot of stress on the research communities and the industry as large. And definitely what we are doing, and that's why I'm super happy to have Jean-Jacques as well, because we have now the ability to sort out through all the papers and make sure that whichever paper we select for you to get and understand and implement is the most relevant one for the years to come. So that's why lifetime access is very important. Yes, Jean-Jacques.
One thing we can add is also, even if they have a lot of new papers, they still have some basic foundations. And that's the main rule we want to give to you, is the way to well understand every foundations of this new deep learning, because it's something that is add or change or tune, but it's one layer over one layer. It's become more and more complex, of course, but if you understand the foundations, then you will understand a lot of other approach that will be very new. So like, for example, PointNet was one of the foundations of 3D deep learning based on point. They have other convolution point cloud like EpiConv, but they have some, let's say, super point approach that's work also with some foundation. And when you understand all the foundation of deep learning, you will well understand new approaches, because you see directly, okay, it's going in this family or in this family, and then you know how it's work in the background, and you can understand what is the change the author did to to create this new approach. So it's really a foundation for understanding future approach.
Yeah, definitely. And I think it's also very important to have this community aspect of things as well. So usually whenever the best way to approach learning, it's like to learn something and to apply it, learning and applying. And at any point, getting out of the comfort zone into pushing out whatever you created with the community. So we have a Discord community. Maybe you can drop that as well after that, Jean-Jacques, for those that want to join that, where we share, like, everyone has a specific track and is evolving in a specific direction, and like having this community makes growing so much more efficient, and like fixing little problems that some people have much easier. So that's also something that I really love here, the 3D Geodata Academy. And and so of course the support also here. I want to make sure that the support that you get for now is either from me or Jean-Jacques, so that you are sure about what you're getting from. So it's the source of information is very stable and foundational, and hopefully that will limit the noise that you have on the web, which is a bit sometimes cumbersome when you have. Like it doesn't mean you need a PhD to know this sort of things. Absolutely not. But I think that's also a note that what you get, you can be pretty secure about the knowledge there. So one thing that aligns pretty well with this workshop is the release to everyone. We did a small like VIP release to the members of the Academy the past 2 months to make sure to adjust the new course, which is the 3D Deep Learning course, which is the biggest course that we made so far. We made it together with Jean-Jacques because here we release also the models, so the classification, the semantic segmentation models as well, and so on. And we definitely need two pairs of eyes, at least, to make sure everything is working properly and everything works for different systems, Linux, Windows, Mac OS, and things like this. So basically, and I'm not exaggerating, Jean-Jacques, I will leave you for the part on GrowSP and this very strong new architecture. Like some models took us at least 6 months to re-implement from scratch or to implement to make them work, and condense that in the course so that you save this time. So only for that, I think it's already a huge stuff. And I don't think I'm exaggerating, right, Jean-Jacques?
Yeah, right. It's really difficult to go from the, let's say, the theoretical way, even if some author provides on GitHub. If you are lucky, the GitHub is not so buggy, but it's still very theoretical and work on one specific application case and everything is tuned for this. And when you try to apply in real case scenarios, you get some nicely surprised that the code is not ready to be adapted. Everything, the model itself is designed in a way that is difficult to implement. Also, they have a lot of libraries that can be very old or are obsolete right now and have to be changed. And also the problem of licenses. If some libraries use GPL, sometimes the code should be GPL, but sometimes the author forget to specify that one library is inside was GPL. So then we have to redo this this library entirely to remove the part of the code that we use this and implement ourselves. So it's usual work. And to answer one question of Jim Lee, it's about mathematics. What is the math level we should have to follow our course on point cloud and work on point cloud and algorithm? You don't need to have a very high mathematical level. It's really let's say bachelor. It's really enough. You don't need to have high level of mathematics. Everything is explained, and it's mainly coding, but understanding the principle, and then it's working.
Yeah, it's the approach here is a first principle approach. So basically breaking down what we believe into, actually how does these things work? And we take it from there, so from scratch. And that's what was like this course, we took 3 years to make it happen because we wanted to make sure that you can get it from scratch. So for the 3D Deep Learning course, definitely it's a good it's good if before you follow the 3D Python crash course, which in 2 hours like go through this mathematical base layer plus some other stuff around 3D point cloud processing. But once you have that, then this is definitely a standalone getting from scratch, because we also cover the neural networks for 2D before moving on to major deep learning architectures that are used in the industry, like ResNet, EfficientNet, and then after moving to the 3D component of things with both the voxel approach, with RCNN or CNN, and the point-based approach with PointNet and the best architecture like KPConf, GrowSP, and so on. And at the end, I think it's also very important to have the final product, so having an end-to-end pipeline where you have your point cloud, your full model, and at the end, the output as an app, right? And that's what we have. And of course, we also did some digging onto all that is linked with generative AI, LLM, hybrid systems. So yeah, definitely that will be something if you are at this stage where you grasp 3D Python, you have an idea that you want to implement, or you want to be an expert with 3D deep learning, which is super in demand right now, then I would recommend going there. Before having this base layer, it's good to dive with the 3D Python crash course, or with all the other free resources online, the YouTube and other people that create wonderful stuff. So now what I do is I will put tomorrow or today, hopefully today, I will put the live session recording, but because of the bugs, I hope it's good, the code with the MIT license and the data sets that we saw, plus the cheat sheet in here. All right, so top open geospatial libraries plus tool for 3D. Yes, if you want me to include anything else in the code, I can also do that, Shirin. That's why I didn't release it now. I wanted to make sure that it works perfectly for you. We go over some common PDAL open 3D tools and workflow you use for your research or project. Yes, that's a wonderful idea, Jean. Let's do that as well. Yeah,
it's linked to what Nick proposed, so it's definitely something we can add our view, have some common points or what open tools, libraries, and yeah, it's a good idea.
Could we please have a session comparing photogrammetry vs NeRF and Gaussian splatting? Yeah, I had that as well. Yeah,
I think it's an advanced workshop on this that would be very interesting.
Yeah,
maybe we cannot go in the code and in the explanations.
No,
the one, so it would definitely high level to explain.
Three workshops definitely there to cover that. Just a short note. NeRF and Gaussian splatting span out of photogrammetry and heavily uses photogrammetric principle, especially structure from motion and dense matching. So it's more a visualization or rendering strategy at this stage, except from the NeRF, which has new elements that actually uses this radiance field to play with the modeling aspects of things. Merci, Florian. Thanks. Do you have any tips for object detection in IDA with deep learning models? Yes. Yes, I have tips for object detection in IDA data. So maybe while I start answering, can you just specify which LiDAR dataset you're using? Is it ARIO LiDAR data, or is it like cars, autonomous driving? Because you have two approaches, let's say, which are different. ARIO LiDAR data. Okay, so my tip is to start with classical approaches or algorithm or rule-based algorithm or 3D machine learning before moving to 3D deep learning. Basically, it's testing existing stuff, and if everything fails, then moving to 3D deep learning. Because usually, you do not need to kill a wasp with a shotgun. I don't know if it's a coherent image, but deploying 3D deep learning for a small application will be overkill. If you are talking about large-scale object detection at a national scale or really big stuff, then it makes sense to go into 3D deep learning. So that would be my first tip. My second tip is making sure that you label data, because usually you go in supervised fashion, is really nice. So garbage in, garbage out. So if you have something really, really nicely labeled, it makes it much easier for your model to pick up intricacies of your data set. So that will be my recommendation. So what I can do as well is show data. I think for that, if you're ready to dive into and to make sure to have the best, let's say, object detection approaches, you can check out there. You have a three. It's a package where you have the 3D object detection course, the 3D machine learning crash course, the 3D deep learning crash course, and segment anything model for 3D. That each gives you a specific approach to semantic segmentation and object detection for 3D datasets. And you will have something that relates to unsupervised learning, DB-scan, and clustering, one that relies on deep learning with segment anything model, and the other two ones with random forest and point net. So I think having that, like you're sure you can find the best strategies for your case. If you already know which is the best strategy, or if you want to dive into everything with deep learning, then it's the new course. I think that will help you there. Hopefully that answers your question. So yeah, I guess we can wrap up at this stage this workshop / meeting. and again, I was really happy to have you all of you guys here. Sorry and congrats on finding the little link in the live event. It will mean a lot if on the event you write in the comments some nice feedback on the workshop, if it was helpful for you. That will help maybe more people find out this kind of resources and not be overwhelmed by the amount of stuff that comes out. And yeah, hopefully help grow this all learning around 3D. Because I have to say also something. I don't know what is your trajectory, but you have two trajectories. With all of that, you can definitely create your own like side business, side hustle, or there are a lot of opportunities either for creating like mass market 3D models, or creating models that you can sell online, or using Python for that, or growing your company and growing your career. There is a huge shortage of experts that can handle 3D datasets and 3D machine learning and 3D deep learning and 3D at large. And if you are one of those individuals, I mean, you have a major hedge over other candidates that knows classical machine learning or classical computer vision and things like this. That's really an objective recommendation. If you are excited about 3D, if you want to make it a career, either for yourself or by creating crazy stuff, definitely it's worth investing into yourself and developing the skills. You can count on me and Jean-Jacques to make sure we can accompany you to the best of our abilities, whether through Discord, YouTube, Medium, the courses, whichever suits you best. Don't hesitate to reach out. You saw my private email address. Please don't use that to spam me. But you have my professional, or one of my professional address on the website. So yeah. Anyway, thanks a lot. And I will be very happy if you can leave a comment in the LinkedIn event, and see you in around 1 month. Don't hesitate to subscribe also to the newsletter. I will send you when the next workshop happens so that you don't miss it. In the meantime, thanks a lot, Jean-Jacques. It was a blast again to be with you. We did not have time to go into the VS Code setup, but hopefully we can do that next time to show. We show Anaconda, we can show VS Code setup. That would be nice.
Thank you very much for inviting me to this workshop. Thank you to all people, and if you can, as Florent say, put some comments on LinkedIn. And if you still have some questions we didn't have the time to answer to you, don't hesitate to put it on LinkedIn, to write on the comment, and subscribe to our YouTube channel, to support our work and help us to to continue this adventure to create workshop every month for this years and having this nice experience with you again.
Awesome. Thanks a lot, guys. Very happy to have you there.